All right, good afternoon. Today we're going to start with chapter 2. All right, chapter 1 later I will give you the full answer for all the tutorial questions. Okay, I'll try to make it as fast as possible. Today we will start chapter 2, random variables and probability distribution. Okay, before we go on with chapter 2, I just want to recap what we have done in chapter 1. Chapter 1, the first thing we learn is basic probability. The second is joint probability. The third one we went with marginal probability. And the fourth one is Bayes' theorem. This was covered in the tutorial, the first tutorial, and I have uploaded the video. This is what we covered in chapter 1. All these are basic, and we go by all these are still there's no systematic manner of learning a probability. Now what we are going to do in chapter 2 is we are going to learn probability in a systematic manner. Okay, chapter 2, learning probability systematically. Okay, sometimes my spelling is wrong, don't worry about that. Now let us learn probability systematically. So in the first phase of how we are going to learn the system is we are going to divide a random variable. So what is random variable? You can read the definition here, but let me go through some examples so that you can clearly know what I mean by random variable. This random variable we are going to split into two. One is discrete, another one is continuous. Okay, another one is continuous. Today we try to cover discrete. We try to cover as much as we can. Okay, when I say discrete, all the random variables, okay, the random variables will take a non-negative integer. A non-negative integer, it starts from 0, 1, 2, 3 and so on. Okay, round figures, single digits. Okay, there's no range, it is given. Decimal it depends. Okay, one by individually, everything is counted by individually, no range, no intervals. Okay, let us look at first example here. Read this example. An experiment consisting of tossing a fair coin 3 times. Let x be a random variable of getting hit. See, your random variable now, the variable or the one we are focusing now, okay, the random variable or the parameter we are focusing is getting a hit. Okay, they're getting a hit. So we denote that random variable by x. Find the probability of getting a hit by using probability distribution table, graph and equation. Now for me to do the number a, we're doing a, let us do some tree diagram for this. This is a fair coin toss 3 times. First time, second time, third time. Now this is tail and head, tail and head, tail and head, tail and head. They say a fair coin, which means the probability for a tail is 0.5 or 1.1 over 2. I would rather write 1 over 2 all the way. First of all, let us find what is the outcome. And then we are going to compute the probability. This will be your x. X is your number of hit. Okay, when I say outcome, there are how many outcome are there? 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So we're going to list down all the 8 outcomes. If I start with first toss is head, first toss is tail. Look at the branch, the green color I'm drawing. It is actually tail, tail, tail. How I know? Tail, tail and tail. This is one possibility for you to get if you toss a coin 3 times. First time tail, second time also tail, third time also tail. So the second outcome would be from here. That would be tail, tail, head. Third outcome, third possible outcome, tail, head, tail. Fourth possible outcome, hopefully you can do without the green color highlight. These are the outcome. These are the possible outcome you get when you toss 3 coins. Now for you to find probability, just now you get tail, isn't it? What is the probability of getting a first tail? 1.2 times. What is the probability of getting another tail? 1.2 times 1.2. 2. Altogether is 1 over 8. For the second outcome, the probability of getting tail 1 over 2. The probability of getting tail is 1 over 2. The probability of getting head is also 1 over 2. Since it's a fair coin, okay, each outcome, tail and head, 1 over 2, 1 over 2. So when you multiply 3 outcome here, no matter is tail, head, or triple tail, head, tail, whichever 3 outcome, you always end up with 1 over 2 multiply 1 over 2 multiply with 1 over 2, which means you're going to get 1 over 8. If you do the third one, the second one is 1 over 8. The third one also 1 over 8. Fourth one is 1 over 8. Okay, 1 over 8. If you plus all the outcome, you should get 1. That is the idea. I give you some time to copy this, in case if anybody copying this. Alright. Now x is number of head. Can you find any h here? No. So x is equal to 0. Can you find any h here? There's 1. Any h here? 1. 2 h here? 2. 1 h. 2 h. 2 h. This is what we are focusing on. How many h is in our outcome? This is 3h. Okay, once you do the tree diagram, then we can present the data, we can present the probability in a much more nice manner. Okay, we can present that, we can show all the data in distribution table, in graph, or in equation. Normally in the question, you will be given or you will be asked to find distribution table and equation. A graph, not a famous kind of thing. Okay, so let us present the data here, the probability information here, in a table first. The x is actually number of head, as you can see here. The number of head x you get is, the lowest number is 0, the next number is 1, the next number is 2, the next number is 3. We write here total. So this is how you find the variable random variables and present this in the table. And the probability for you to get 0, you can see here the probability for you to get 0 is 1/8. The probability for you to get 1 is 1 here, another one here, another one here. When you go by branch, you multiply. So just now 1/2 times 1/2 times 1/2, you get 1/8, isn't it? But whenever you want to jump from one branch to another branch, okay, whenever you want to jump to find the probability, you plus. Okay, you plus, you will get 3/8. The probability of getting 2, I no need to circle that, you can easily see that is exactly the same like number 1. The probability of getting 2 is 1, 2, 3. What you have to do? Plus everything, 3/8. And the probability of getting 3, that is only 1/8. If you plus all, you get 1. And the notation for probability, normally we will write it as capital X equal to small x, or in this case, for this syllabus, you can only write px, enough. Okay, this is probability distribution table. They also ask you to draw a graph, so we will do that now. Probability distribution graph. Over 8. Now my x is 1, 0, 1, 2, 3. The probability is 1/8, so you pull out point here, you draw a line here. Okay, this is how you draw a graph. The probability for 1 is 3/8, you plot a point here. Two is and 3 is this is how you draw probability distribution graph. For the equation or function, okay, we call that as equation. How I normally write this as a function. Let us do this probability distribution function now. For probability distribution function, just now we saw that from the table that the probability is 1 over 8 if x is equal to 0 and 3. Okay, you can see the table here. When x equal to 0 and 3, the probability is 1 over 8. 1 over 8. The probability is 3 over 8 if x equal to 1 over 2, and it is 0 otherwise. You just complete this. If other than 0, 1, 2, 3, if you have any other value of x, that the probability is 0, and this would be the function. So you have seen now how we distribute the probability, okay, how we present the probability information in terms of three methods. One is table, one is graph, and another one is equation or function. Okay, out of these three methods, table and function is we use very frequently compared to graph. Okay. Now for B, prove that the distribution is discrete probability. For you to prove that a distribution is discrete probability, you need to prove two conditions. The first condition is you must make sure the probability is in between 0 and 1 or equal. So let us check whether the probability is between 0 and 1. Check. Whether the probability is between 0 and 1. Let us go back to the table. If you notice in the table, this is 1 over 8, this is 3 over 8, 3 over 8 and 1 over 8. All these are in between 0 and 1. Therefore, the first condition is fulfilled. You write there. The probability is in between 0 and 1 for all x. Okay, that is the first thing you have to check. The second condition you have to check is if you plus the sum of the probability must be equal to 1. So check whether the sum of probability is equal to 1. So let us check. We know that the x is from 0 to 3. So the summation of x 0 to 3 px must be equal to 1. If you plus this, you get 1. Therefore, so it fulfill two conditions. First, the probability is in between 0 and 1, and the summation is of probability is 1. Therefore, the distribution is a discrete probability distribution. This is the answer for the first part of B. For the second part, they ask us to find the probability of Px less than 2. So I'm going for next page now. For me to Px less than 2 is actually equal to x equal to 0 is 1 over 8 and x equal to 1 is 3 over 8. This would be 4 over 8 and you can write it as 1 over 8. This is the answer. Px equal to 0, that would be 1 over 8. Px equal to 1, that would be 3 over 8. Px equal to 2, that would be 3 over 8. All this probability I am taking from the table. Summation is 7 over 8. For this one is x equal to 1, x equal to 1 would be 3 over 8, x equal to 2 is 3 over 8 and plus is 1 over 8. Again this is 7 over 8. You can solve this. Number 3 is like this. Or just now the variable was 1, 2, 3. Am I right? So when they said equal to 1 or greater than 1, equal or greater than 1, you choose the probability of 1, 2 and 3, you plus, or what you can do, another method of doing this is find the total. This is total probability, and we know the total probability is equal to 1. Total probability, we actually want 1, 2, 3 is because it's greater or equal to 1 minus the probability of 0. Okay, so in other words, this one you minus. This is the answer. So in other words, if they want, what you do, total, which is 1, minus this one. This is and if you do this, you will get the same answer, 7/8. Okay, whichever is convenient for you, whichever you understand.